So on to page 93, we have this series going from n equals 0 to infinity. All this good stuff here. It has very much the same feel as something that would be ratio test. Right? You could also look at something like C along the same lines. You know, you might get a little bit of a different feel when you get to D. All right, but let's start off with B. It has that alternating aspect to it, but we learned 3 pages ago? I forget. But we learned a little while ago that the ratio test still applies even for alternating series. All right, so we can jump right in here, or we can give it a look using alternating series, but that could be a little crazy when you start getting into the X. All right, so let's identify an a sub n plus 1, assuming we're going with the ratio test here. All right, so that's going to be -1 to the n plus 1, x to the 2 times n plus 1 plus another 1 over same deal. All right, so it behooves us to simplify this first. That's 2n plus 2 plus 1, so 2n plus 3, so that's going to be 2n plus 3 factorial. Alright, so when we set this up, we need the limit as n approaches infinity of the absolute value. I'm going to write this as -1 to the nth times -1. Then x to the 2n times x to the third over, on the bottom here, whether it's this one or this one, we can manipulate one to get the other. So what I'm going to choose to do is manipulate this by saying this is really 2n plus 3 times 2n plus 2 times 2n plus 1 factorial. Then we're looking at -1 to the n, so now I'm working off of this, times x to the 2n times x to the first over 2n plus 1 factorial. Close it up. Now this whole thing should have a value less than 1. Alright, so I have across the top, cancel, 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 partial cancel. Then just one final cancel. Alright, so I'm going to pull the x squared out of the whole thing like I did before, last problem. Limit as n approaches infinity of -1 over 2n plus 3 2n plus 2. Alright. So this is a nice little situation here. Because of so many cancellations, this whole thing here just zeroed out. Right? Power on the bottom bigger than the power on the top. And so what we're looking at here is something, and this is a very familiar problem. I mean, we pretty much did this one already. This is the so that's the sine function, sine of x. All right, so this is an instance where the interval of convergence is negative infinity to infinity. All right, so the center would be 0. All right, and that's pretty typical. When you think of a Maclaurin series for sine, that's what you come to expect. Now for part C, there's a lot more going on with this one, but it's still going to follow the same kind of setup. So -1, if I throw in an n plus 1 for n, some cases it's easier to do, in other cases more challenging, but in this case it's not that bad. N plus 1 plus another 1 is n plus 2. X minus 5 to the n plus 1. N plus 1 to the, or times 2 to the n plus 1. All right, I like breaking things apart. There's other ways to do it, because you could look at this as saying -1, to the n plus 1 times a -1, you know, and then use that to cancel it out. It's really up to you, but I'm going to write it for better or for worse in a way that makes sense to me. Which usually works out. I still want to do the 2 to the nth first, and then the 2. All right, so just busting it all apart. So this divided by the original, but like I did in the previous one, I'm going to take the original and sort of clean it up a little bit. So -1 to the nth times -1. X minus 5 to the nth. You know, so when I say clean it up a little bit, I really mean a little bit. We're finding the limit as n approaches infinity of this, and it should be less than 1. All right, and then we go through and we have the, you know, remember you're in your algebra days, the joy of all the cancellations when they happened. It was really nice, so let's do it. Right? Well, -1 to the second is really just a 1, so that goes away anyway. Gone, 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 gone. Looking at everything here. I think I got everything. Okay. So, limit as n approaches infinity. All right, so I got that x minus 5 up top. I'm stuck with that. In fact, let me do it this way. I have an x minus 5. I have a 2 and an n plus 1. Now on the bottom I have, I'll use my highlighter here, a -1 and an n. Keep, change, flip. It's going to put the n up top and the -1 on the bottom. All right. So we got a little something going on here. But that x minus 5 is a little troublesome. Don't particularly care for that, but we can work with it. All right, so now the limit of a absolute is the absolute of the limit. I'm going to distribute the n. So nx minus 5x. On the bottom, it's up to you, but I'm going to distribute it. -2n minus 2. I can bust up the fraction based off of this subtraction sign. Why did I put a 5x? Nobody knows. Nobody really knows. 5n is what I wanted. All right, so yeah, nx minus 5n. Everything looks good here. Still absolute, I don't want to forget about that. So for the first one, I can take out the x. So x, limit as n approaches infinity, of n over negative 2n minus 2. Minus, now this other part I can just handle straight away. All right, because I got equal powers, so I can just take the ratio of the leading coefficients, so negative 5 over 2, so it's going to become 5 halves. All right. Now this part I can also handle right here. All right, so I'm looking at negative 1/2. So x times negative 1/2 plus 5 halves is less than 1. So negative 1 is going to be less than, now the x times the negative 1/2 is negative 1/2 x, plus 5 halves is going to be less than 1. All right, so using the inequality, absolute inequality techniques. All right, I'm going to subtract the 5 halves from both sides, all sides. So negative 2 halves minus 5 halves is negative 7 halves. And then 2 halves minus 5 halves is negative 3 halves. Multiply everything by a negative 2. That's going to reverse all the signs. So 7 greater than x greater than 3. All right, so there's a lot of stuff going on with this problem, not the least of which is going to involve us evaluating those endpoints. All right, so I'm going to take that 7 and plug it in for x, and then I'm going to plug in a 3 for x and see what's going on there. All right, so x equals 3, x equals 7. All right, so I got the negative 1, the n. So basically everything except for this is going to stay the same. All right, so I'm going to have my negative 1 to the n plus 1. Was it 0 or 1 on the bottom? It was a 1. We're going to have the 2, the n, 2 to the nth. And then the last piece here is dependent on what we're plugging in. So if I pop in a 3, I'm going to get a negative 2 to the nth. If I plug in a 7, I'm going to get a positive 2 to the nth. I'm liking that positive 2 to the nth a whole lot more. All right, because that's kind of an asked and answered sort of thing, right? So this is an alternating series. The limit as n approaches, so you know, the a sub n is going to be decreasing, right? Because we're going to have a 1 over n, 1 over 1, 1 over 2, 1 over 3. It's always decreasing. As n approaches infinity, of 1 over n is going to be equal to 0, so it converges. For the other part, and a little more work to do, but just as fun, that negative 2 to the nth can be written as negative 1 to the nth times negative 2 to the nth. So let me just do that. We'll be able to cancel the 2 to the nth, so that's great. Now, something interesting kind of happens. All right, so if you kind of play this out logically, if you plug in a 1 for n, this becomes even, so that becomes a positive 1. This becomes odd, so this becomes a negative 1 as a result. So overall, it's a negative 1. If I plug in a 2, this is odd, that's even. So this one is a negative 1 as a result. This one's a positive 1 as a result. Bottom line is they multiply to equal negative 1. If I plug in a 3, 4, so even exponent gives us a positive. 3, odd exponent gives us a negative. Bottom line is, long story short, we're getting a negative 1 on top no matter how you slice it. All right, so this got rid of the alternating series part of it. This made it a p-series test. All right, this is an exponent of 1. P is equal to 1, therefore it diverges. All right, so we're looking at the interval of convergence is going to be the 3 worked, the 7 didn't. So 3, wait, sorry, got that backwards. The 3 didn't work, the 7 did. So 3 less than x less than or equal to 7. The radius of convergence split the difference, we're going to have a 5, right smack dab in the middle. Sorry, that's center of convergence. I didn't really give myself enough room here. The radius of convergence would be 2. And so we got there. It's just, it took all of this to get there. It's a journey, but it's a fun one. Now the last one, that's more of an interesting situation because we have n factorial and then we have the x minus 3 to the nth power. Doesn't look like anything that would be nth rootable. We'd have to take the nth root of the top and the bottom. So just looking at it, it's like, well, this doesn't look like anything that we've done before. But if we just kind of rely on what we know, and that is when we apply the ratio test, things tend to cancel out. Why don't we try that? All right, so let me get an a sub n plus 1, sorry, which is n plus 1 factorial x minus 3 to the n plus 1. So limit as n approaches infinity of, now I'm not going to write it because I know I want to be able to cancel things out. It's going to be the ratio of a sub n plus 1 over a sub n. I'm not going to write it as n plus 1 factorial. I'm going to write it as n plus 1 times n factorial times, instead of x plus 3 to the n plus 1, I'm going to write it as x plus 3, minus 3 to the n times x minus 3. And that whole thing will be over n factorial times x minus 3 to the nth. All right, and so looking for cancellations, we have a plenty. The x minus 3 is irrelevant to the limit. All right, so I can break it up though, just in case I'm doubtful, but it doesn't have an n in it. You know, if I want, and by break it up, I mean distribute it out and break up the limit. But it doesn't have an n in it, so I can pull it out of the whole thing. So limit as n minus, limit as n approaches infinity of n plus 1, because everything else zapped away, has to be less than 1. So this limit is going to go to infinity, and as it turns out, the only way for this to actually be a convergent situation would be if this amounts to a 0, right? Because otherwise it's some other constant value multiplied by infinity, which is just infinity. So if I say that x minus 3 is equal to 0, I get x equals 3. This would be, it's kind of weird to say this, but the interval of convergence is going to be equal to just 3. All right, the center is going to be 3. The radius